I'm going to discuss about this packaging, which is important for your assignment, and this is to be follow as a guideline. I'm Dr. Sarananda. I'm senior lecturer, the Department of Biosystems Engineering in Faculty of Agriculture and Plantation Management at Wayamba University of Sri Lanka. If you look at the aims of packaging, which include the purpose of doing that one actually is prevent physical damage. That is most of the important thing. Our food must be protected from damage, and also prevent contamination from microorganisms. So that is also mostly important thing in case of in the processed foods, where this microbial contamination is possible after processing. So which prevent the contamination so that our food shelf life can be increased. And also this protect against from dehydration or dampness. So moisture content of a processed food should be maintained as it is until it is consumed. If there's a reduced moisture, that's called dehydration, it change the food. And also similarly increase the moisture content is also change the food system, so that quality will be changing. So we have to protect the moisture level as it is when it was processed, and protect the product's nutritional and sensory characteristics. If it is a food product is prepared, so it has a nutritional quality, and also it has its own sensory characteristics, and all these must be retained until it reach its expiry date. So for the consumer satisfaction. So only way of protecting those things is through the packaging. And also keep the product in peak condition. So that means the sound condition, so without deteriorating its quality, and help to increase the product shelf life eventually. And the marketing conditions, what we expect is to keep the specific time period without causing any microbial spoilage and without changing any nutritional and sensory characteristics, and without changing physical nature and condition, chemical reactions and other things until expiry date. So based on that we can understand, and packaging does a lot in this in the food industry. And also in addition to that, those protection provide from the packaging material, and packaging also provide information about the product to help the customer. The information supplied must cover name of the food, so product name should be there. That is actually towards labeling requirement, and this should be done on the package. So therefore this is also comes under packaging. And weight, volume, so how much it is there, and list of ingredients in descending order of weight, and it's a must requirement. The ingredient used for the preparation of food should be there in descending order, right? How the food should be stored where appropriate. Now to keep this packaging performance properly, and there should be a storage requirement to keep those, and either ambient temperature or the refrigerated or frozen storage, whatever, it must be mentioned in the label. The date when the food should be eaten, so that means the expiry date. Expiry date should be given, and genetically modified ingredients and allergens. And in the food industry now it is becoming more and more popular, and if the genetically modified ingredients are being used, you have to declare that genetically modified ingredients being used. And also if the food contains some allergens, because some people are prone to subjected to allergens, so therefore we have to tell them in label so that they can omit those food if it is allergic to them. And the name and address of the manufacturer or distributor, so that means if anything found wrong on that one, so it must be traced back to the producer to warn them, and also to this not to do the same problem again. And nutritional information on the back of pack, and also this is from 2016 onwards, so it is requirement now, so nutritional information should be given, it must be given. So now once you select a proper packaging material for that one to protect our food, and so this under good condition, and also in addition to that externally these must be given for the consumer point of view, so that then only packaging is fully completed. Now let me see some of the advantages and disadvantages associated with different packaging material we use in the food industry. And so these basic things, actually we are using glass, mostly glass bottles and glass jars, and we are using containers, those are metal. There are different type of metal containers, and also we are using paper still and some plastic. Now if you look at this glass, so it is excellent barrier properties against oxygen and moisture, so the food is protected well. However, it has some disadvantages: easily breakable, so they are fragile and relatively heavier. So when you come to metal, excellent barrier against oxygen, moisture and light. So the food is very well protected, and good mechanical strength and durability. So it is so we can keep them long, and good thermal stability. So that means once you seal the container, food container, the container itself can be exposed to sterilization condition. So it is thermal stability is there. And when you come to disadvantages, it is susceptible to corrosion, and metal cans are generally more difficult to open and reseal. If it is open, you can't reseal it. Paper, of course, it is used, but it is not a very good packaging material. Relatively inexpensive, and excellent printability and lightweight. But there are some disadvantages: poor gas and moisture barrier, and greatly reduced mechanical strength when wet. So this is the biggest problem in the paper is having, and it won't supply proper requirement, proper conditions once the paper get wet. Of the packaging materials, now plastic is the majority of those foods are used now. It is the most changing and challenging material. So it is most versatile packaging material, can be formed easily into many shapes, and also it is lightweight and have many advantages on those. In addition to that, this plastic more suitable, susceptible to migration and flavor scalping problems. So depending on the material, and so there can be migration of these flavor compounds, because plastic having some monomers which can diffuse into the food, which change the taste of the food. So therefore we have to select proper plastic, and not to change the taste of these foods. Now when you think of these materials used for this one, so we can see in the different things, and tomatoes, whatever things, so that many things in the cans, and sterilize containers in those. And so you think that it's plastics. It's mainly useful as low yogurt posts or yogurt cups and crisp bags, and to form that one, and also drinks and containers, some of those. Right, when you come to metals, most of the drink cans, food tins and biscuit tins. And when you come to glass, so it's just bottles and jars are widely being used. And paper and card, so milk cartons, general food wrapping. Right. When to come to this packaging, now in the industry, this packaging is not used only for the above function. Now it's a further is gone in, so as a result of that, a new packaging technique is developed that's called active packaging. Right. So something doing actively involved in this maintaining of shelf life. So what is active packaging? Active packaging refers to the incorporation of certain additives into the packaging film or within packaging containers with the aim of maintaining and extending product shelf life. So that packaging material as some additives has been added to extend the product shelf life. So another, actually it is actively involved in those, so that's why it's called active packaging. And this packaging may be termed active when it performs some desired role in food preservation and nutritional quality other than providing an inert barrier to external conditions. So it is so external conditions, we discussed about these things previously, and so that now the things, so this so it helps in preserving quality of the food. Now the active packaging includes additives or freshness enhancers that are capable of scavenging. Right, so that scavenging means removal. And so in certain, so in the especially this live fruits, and so this we have to reduce the oxygen level so that to increase the shelf life. And also processed food also we have to remove oxygen to prevent oxidative reaction. So we can use this active packaging with scavenge oxygen. And there are some absorbing carbon dioxide. Now through the respiration of the fresh produce, there is a production of carbon dioxide, and excess carbon dioxide accumulated, if it is accumulated more, there can be CO2 injury. So therefore absorbing carbon dioxide is also another important, and also absorbing moisture. And sometimes especially in the fresh produce, if produce is stored in, there is a condensation of moisture which cause some disease problem. So therefore there are some active packaging produced to absorb moisture. And another thing is ethylene or flavor or odor taints. And if it is food is packaged, especially these fruits, and so that with the liberation of ethylene, it enhances the ripening process. So as an active packaging, is ethylene absorbent is used, so the ripening can be delayed. Right. Similarly, there are some flavor and odor taints which can be removed. And releasing ethanol, sorbates, antioxidants or other preservatives. By doing that, we can reduce those things, and so there are specific functions, so that ultimate objective is to enhance shelf life of the product. And maintaining temperature control, and also temperature control also can through the packaging material. Now, when you think of these practical examples of the intelligent packaging, so this active packaging does actively something, so removal or addition or this thing, so some action is there. Now, in addition to that, what intelligent packaging is, so it track, sense, communicate. Track, sense, communicate. Right. Now you can see this type of salads that are there. So now there's a color code is given here, and so this track the product and sense the environment inside or outside of the package. So now one thing is developing here. It's there are some production of ethylene or high CO2. There are many mechanisms are there, and in response to that one, so it is looks like the initiation of deterioration. It's not fit for consumption. So there is a color change is given. So there is a band colored thing. So it is developing, and with this sensor, so we can remove if it is not suitable for consumption, right? So that type of materials are called as intelligent packaging material. Now again, say same thing, this intelligent, maybe it is better term is intelligent packaging here, and so that brightness sensors, the ability to change color as the contents changes in brightness. Now you can see these type of things are there in the label, so it is given, and if it is shown that, now we can see what the color response is once this thing, so that based on that one you can understand. So it is at what stage should it ready to eat. Now it is in this case this one, so till then you have to keep them inside the bag. Okay. When you come to the selected examples of those things, active packaging systems, and so these oxygen scavengers, so that so these are the mechanism of these things. So this can be iron based, where you can find in the jumbo peanut, and metal acids, metal catalyst, ascorbate, metallic salt, enzyme based. Right. So there are different mechanisms to remove or scavenge those different things. So there's a lot of examples are given, those are being used in the industry. I'm sorry about that. Carbon dioxide scavengers are also there. So there are different mechanisms to do that, and with this food application. So you can see that different techniques are being used for different things to remove. So removal of oxygen, ethylene, it is very important because in the fresh produce handling, if excessive ethylene is accumulated, the quality goes down and there is a senescence initiated. So therefore we have to scrub or scavenge ethylene. So widely used is potassium permanganate, activated carbon, and activated clays and zeolites. So these are being commercial use there, so that we can also generate some of these innovative products. And active packaging actively changes the condition of the package food to extend shelf life or to improve food safety or sensory properties while maintaining the quality of the packaged food, right? So this active packaging may involve antimicrobial products, addition of carbon dioxide, ethylene absorbers, oxygen scavengers. So these are the major things involved in active packaging. When you come to this different packaging polymers, so that means polymers or long chain macromolecules that can be molded, extruded and cast into various shapes. So you can see these different shapes are coming in the different thing. And mostly used films are polyethylene, polypropylene and polyvinyl chloride. And natural polymers there are can be innovated from this starch, protein, cellulose. But the problem is poor oxygen and moisture barrier and weak mechanical strength. Once we increase the once you increase these compounds, different things, so that means biodegradable property and other things, so that mechanical strength is reduced. Now, in the food industry, this has been happening this as an oxygen scavenger used in crown caps, and crown caps is, so the scavenger is based at the inside the base of the lid, and if there is oxygen is produced, this oxygen is removed, scavenged, so oxidative reactions are reduced. So there is a, and in addition to that, we can use these ethylene absorbers to improve the functionality of those foods. And the fruit crate, fruit flesh made from corrugated cardboard. Cardboard uses the hollow spaces between the corrugations to apply active materials. So there's a kaolin and zeolite in this case, and these are working as an ethylene absorber. If packages go with this ethylene absorber, so there is no accumulation of ethylene to initiate autocatalytic ethylene production. Now, selective permeability. Now, in case of fresh vegetables, so it is different sometimes. So they are highly respiring. So therefore, the normal polyethylene will not do, because it should allow more oxygen to penetrate. In certain foods, low oxygen to penetrate, and so there are different length we want to require. So based on that, we can use this selective permeability. So the different films. So where this oxygen level will not go down very low level. So therefore that we can adjust those, and by doing that we can set the permeability. And active agents for releasing systems, mostly these antimicrobial agents. There can be organic acids, sorbate, propionate, benzoate, because of acidity nature, and so this working as that antimicrobial agents, and bacteriocins, enzymes. And when you come to disadvantages, you can use antioxidant agents, and so this BHT, vitamin E, vitamin C can be added. When you come to the biodegradable packaging, so those are becoming more and more important, because these cannot be decomposed quickly. So therefore we need the biodegradable portion of those. So there are many information available in regarding this biodegradable material that's lived, so normally it degrades automatically. Now, as an alternative of this polyethylene and other things, so this bioplastics can also be manufactured, and using plant oil, cellulose, cornstarch, potato starch, sugarcane, many things. So these are actually cheaper way of doing that, and also those can be some various things, and so these different sources of materials are available. So we can go for the preparation of materials. And food safety, consumer acceptability and regulatory issues also need to be concerned. Now it's still a consumer point of view, there's regulatory giving some different foods So we have to take care of those. Food safety and regulatory issues related to active packaging of food need to be addressed. So there are now most of legislations are coming day by day. First, any need for food contact approval must be established before any form of active packaging is used. So we cannot simply produce active packaging. So we have to get the approval for that type of things, whether it is working properly or not. And second, it is important to consider environmental regulation covering active packaging. So active packaging looks like it's popularizing, and it gives specific functions to extend the post-harvest life of those, so that there will be less waste. And so this, however, there can be, should be, we have to consider the environmental regulations before producing an active packaging. And once you use this many packaging materials, so we have to take care to prevent this environmental pollutions in that one. So therefore, what we have to do is we can remove the many things, packaging materials, alone things, and reduce. Use of packaging should be reduced and reuse. If the packaging is produced and we can reuse them, so that by increasing the number of used and new production can be hold down, reduced, and recycle. So there's most of those things, once it's produced, it must be ability to recycle, so that we are using again and again those, so there won't be any big problem. And also recover and material or energy, and we have to spend on those. So now so that we can see that most of those things have to be concerned, keep in mind when you are taking care of this packaging. Thank you very much. That's all. I hope that you got some information about this packaging, and based on that, so you can think of that's your assignment.